Hey guys, welcome back to another problem solving tutorial, and in this tutorial I'm going to be showing you guys how we can solve problem 206, which is asking us to reverse a linked list. So in case you guys don't know what a linked list is, it's basically just like, it's not really similar to a regular list except for the fact that it stores items. So it's comprised of nodes, and then within these nodes we just have a value and a pointer to the next node. So let me show you guys how you would create a linked list function or object to represent this array. You can see I have the class here, which is provided by Leetcode, and if we wanted to create the object 1, 2, 3, 4, 5 like that, we would do something like this. So the first list node, this is going to have 1 in it, and then the next is just a pointer to another list node, like so. This one contains 2, and same thing here, pointer to the next one, which is 3, and same thing on and on until you get to 5. And then here, this doesn't have an item after 5, so what's going to happen is we're just going to put null in the pointer to the next item. So there we go, and that's the linked list for representing this array. But anyways, the question is asking us to reverse a list. So the thing about linked list problems is that it's always good to visualize them and visualize switching around the pointers. So here I have just a simple paint, and what I'm going to do is just draw out this linked list. So let's do 1, this is pointing to 2, which points to 3, which points to 4, which points to 5. So you might notice that if we want to reverse a linked list, all we actually have to do is just reverse the direction of each pointer, and then this becomes a new head. So the head is the first item in a linked list. Firstly, in the original one, the head is here, but if the new one, the head is here, and then we just reverse all these pointers, that's going to reverse the linked list for us. So we want to figure out how we can get from here to here. And what I'm actually going to do is, let me create 2 variables. So I'm going to split this up into, okay, so what I need to do is I first need to reverse this first pointer like so, but what you'll notice is that if I reverse this, then everything after this pointer gets erased because I've basically gotten rid of this pointer. I've gotten rid of this one, and this is the only thing which is keeping all of this stuff like accessible to us. So when I reverse this, I also need to make sure I store this somewhere else. So what I'm going to do is I'm going to create 2 variables. I'm going to create let's just call this reverse list. Actually, I'm just going to call it list for now, just because it's easier to spell, just because it's easier to write. But so we're going to have 2 variables. We're going to have the list, which is just going to start off as the first item in this input, and then we're going to have the storage. And the reason I'm calling it storage is just because it stores the other stuff while we manipulate just the first pointer. So storage, this is 2 to 3 to 4 to 5, like so. And essentially all we need to do now is, for each iteration, we just need to take the first item from storage and move it over to connect to point to this list. So if we do that for 1 iteration, you can see what's going to happen is the list is going to become 2 pointing to 1. And after we've done that, we also need to remove this from this, remove the 2 from the storage, so that the storage simply becomes 3 and onwards, like so. So 3, 4, and 5, like so. And then we can just keep on repeating this process, move the 3 over to there, and delete it from this, until eventually we have list equals the reverse list up here with these green arrows, and we have storage, which is just equal to nothing because this 5 has been moved over to here. So storage is just going to be equal to null or empty. So that's the basic idea of how we're going to reverse a linked list. It's quite complicated, and there definitely are easier ways of doing it. Like one way would be to just create a new list for each time, and that might actually be fast as well, but I think this is a good way of thinking about it because this kind of methodology is useful later on, manipulating the pointers. Okay, so let's start implementing this. And the first thing I'm going to do is I'm just going to manage any edge cases. So we're given a head, and this is actually just a head to this entire thing. What I'm going to do is, first of all, I'm going to check whether the list is 1, or if the list contains any items at all. If you are given 0, if you get nothing, then just it's going to cause some problems. And if the list contains just 1, then we also want to just return that 1 item. So we can do that fairly easily by checking what's the issue here. Okay, let me just do this, and we're just going to copy this. There we go. Okay, so the way we can check if the list contains more than 1 item is pretty simple. We can just check if the head is equal to null, that means the list is empty, or if the head.next is equal to null, well, that means the next item is empty, so the head only has 1 item, therefore the list only has 1 item in it, and in these cases we can simply return the list as it is, because there's no need to reverse a list which only has 1 item in it. Okay, now that we've got past these edge cases, let's just write, we know the list has 2 or more items in it. Now we can actually start. So the first step is to split into the list and the storage. So we have the list, and we actually need to define the storage first, because if we, the way we define list is by doing let list equals head, and then what we do is we just do list.next equals null. That's how we define that, but that's probably not the best idea. What you might notice is that we can actually just use the head as the list itself. So let's just take the storage. We're given this entire thing. All we're going to do is we're going to assign storage to these 4 and then delete them all from the head. So let's say let storage equals head.next, because remember, if we take the next, that's going to give us everything here. So we've taken all this in storage, and then I'm just going to delete that from the head, so we're going to make it null. That's equivalent to getting rid of all of this and just make it null, like so. Okay, there we go. Now we're ready to start. So I'm going to put this all in a while true loop just for simplicity, but obviously if you wanted to, you could do it while storage is not equal to null. That would work as well, but let's just do while true so we don't have to think about it too much, and we'll add a break later. So the steps are, we want to take the first item in storage and we want to assign it as a pointer to list. So one thing, what you might notice though, is if we change the pointer of 2, then this pointer disappears, so we're losing all of this, which means we need to store it temporarily. So let's call that temp storage, and that's just going to be the storage.next. So now we've stored all of this, we're free to now change the pointer of this first item in storage. So we can do storage, the first item, and we can just make this next is equal to head, like so. So we're changing a pointer to point to this. And once you've done that, that's actually it. So we can go ahead and, if you imagine, that's just going to move that over to there. And now in storage, what we'd have is we'd have just list would be, oh, right. So what would happen is we'd still have list equal to 1, but storage would be equal to 2, 1, like so. And we have all of this stored in this extra temp variable. So we need to go ahead and reset for next iteration. And the way we're going to do that is just by assigning list to storage, and then we can just put all of the temporary stuff we got rid of as storage back. So let's just put head equals to storage. We're changing this to just assign to this here, and then we're just going to set storage as the temp to get rid of this. Okay, there we go. And what's happening here? Okay, let me just change this to list node or null. Okay, my bad. TypeScript is just acting up, but I think we should be able to solve it. Or okay, I'm just going to change this to a let. Oh, okay. Type list node / null. Let me write that it's possible to do that. And then why is this? Okay. I'm not sure why it's worrying so much about objects being null. I'm just going to try and ignore that for now because it's not important to what we're actually doing. Why is this care so much? Okay, I'm just going to say any. Just get rid of that for now. Okay, so we've assigned the storage as the temporary, so we just assign the storage back to all of this, and then we're going to reset. So now I can actually implement that technique of breaking out. Either I can implement it here, so if storage is equal to null, if storage is null, that means all of these have been moved over to the normal list, and then we can just simply return the head because that's where it's stored. Or alternatively, we could just do while storage is not equal to null, and then when it breaks out of there, we just return head. That would also work. Either of the two would work, but anyways, that should be the solution. Hopefully you guys can understand. Now let's put this into Leetcode and see if it works. Okay, and it's quite slow, but I think that's just a bit of unpredictability because earlier I got a 56 and that was quite fast. So yeah, thanks for watching, and that was how you solve Leetcode question 206 to reverse a linked list. See you guys in a future tutorial. Bye.